Assalamualaikum and hi everyone. So today we are from group 4 and we will present to you how to solve linear and integer programming with Access Solver and C programming of Python. Before we proceed to our presentation, I would like to introduce my group members. My name is Nurhanis binti Safai and we have Nur Atira binti Ishaq, Nur Farisha Fatin binti Zainuddin, Siti Zulaika binti Zakaria and Nik Habibatul Amalin binti Hussein. Excel Solver can be found in Microsoft, while C programming or Python we need to download it and install it in our PC or laptop. That can be used to solve linear and integer programming. For the Excel Solver, we only need to add solver add-in and we are able to solve the linear and integer programming. While for the C programming of Python, we need to turn in into some kind of code to be able to solve it. So we continue to my questions. Okay, from my question, it was involving the Lorenzo manufacturers, which have produced two kind of chair, which is TX and GX model. So there are also some constraints, which is assembly department, finishing department, and quality control department. It also bring profit 50 ringgit for TX and 60 ringgit for GX. So we need to find the optimal production for each model. So firstly, we need to distinguish the variable in the question. So we mark as x1 and x2, which is units of model TX and GX produced per hour. So the objective constraint is max z equal to 50x1 plus 60x2. And there are some constraints from assembly department, finishing department, and quality control department. There are from the workers minutes of their working hours and the machine used for the jobs. For the sign restriction, it is x1, x2 more than 0. I am using Maple. So here we use with floats and we have to include our constraint as I mentioned above. So here we need to point out at what points we need to stop. So here x1 I made it 1 to 100. For x2 I made it 0 to 60. For the option visible is you can have what you want to be your color visible region. So here I choose yellow. And for the option excluded, I put it as white, so it's easier. When you press enter, you will see the constraint that you put it above. So as a result, we have this kind of graph. Okay, so next for the so here we use EQ SN1 to convert it into equality. So when we solve it, we have the equation as 1. Here you see that from the screen. So next we use simplex. Okay, so next we have to use with simplex. We included the constraint that we have and the objective function. So then we need to solve maximize sequence CSI. That's it for the constraint 1 to 3. If we have 6 constraints, then we have to put CSI I equals to 1 to 6. Okay, and it also non-negativity, as we know x1 x2 more than 0. When we solve it, we have the answer. The answer is 1325. The optimal solution is z equals to 1325, and the x1 is 17.5 and x2 is 7.5. That's all for my questions. So we next to next questions.
Assalamualaikum. I am Nur Atila Anis, so I will be presenting on question 2. For the question 2, Encik Ahmad has two farms that grow potato and yam. Because of differing soil conditions, there are differences in yields and cost of growing crops on the two farms. The yields and costs are shown in table below. Each farm has 100 acres available for cultivation. 11,000 kg of potatoes and 7,000 kg of yam must be grown. Determine a planting plan that will minimize the cost of meeting this demand. So this is the table of the yields and costs of Farm 1 and Farm 2. Okay, move to the objective function and the constraint. The question asks for determine a planting plan that will minimize the cost of meeting this demand. So we know that we want to get the number of acres of yam and potato. Since we have farm 1 and farm 2, so we will separate these two farms and we will get our variable, which is x1 equal to number of acres of farm 1 planted yam, x2 is number of acres of farm 2 planted yam, y1 is the number of acres of farm 1 planted potato, and y2 will be the number of acres of farm 2 planted potato. As for the objective function, it asks to minimize the cost. So from the table, we know that the cost of yam per acres farm 1 is 100 and farm 2 is 120. So for the potato, the cost is 90 and 80. So we put this data into our objective function. We will get 100 of x1 plus 120 x2, 90 y1 and 80 y2. So our constraint is we from the question it say that each farm has 100 acres. So it will be less or equal to 100 for each farms. And we know that each farm planted yam and potato. So we say that x1 plus y1 is less than 100. Same goes for the farm 2. It has less or equal to 100 acres. So x2 plus y2 is less or equal to 100. And then it says again that 11,000 kg of potato must be grown. So it must be more or equal to 11,000 kg of potato and more or equal to 7,000 kg of yam must be grown. So from the data, we know that yam yield per acres we grown 500 at farm 1 and 650 at farm 2, and it must be bigger or equal to 7,000. So we put it our constraint, it will become 500 x1 plus 650 x2 is bigger or equal to 7,000. And then for the potato, 400 x y1 and 350 y2 is bigger or equal to 11,000 kgs. So and then we put our sign restriction, which is x1 x2 y1 y2 is bigger than 0. Okay, so I'm using the Python in order to solve our linear programming. First thing that we must do is import the pub from the library. And then we define our variable, which is x1, x2, y1 and y2. Since our sign restriction is x1, x2, y1 and y2 is bigger than 0, so we put low bound is equal to 0. And then we have to define the problem and specify our objective function, whether we want it to be maximum or minimum. So I define define my problems as minimum value. So after that, we must denote the objective function. So we put LP prop equal to 100x1 plus 120x2 plus 90y1 and 80y2. And then we put our constraint. So this is our constraint. And then I want to show the problems in our output. So we put LP problem, print LP problem. So it will print out all our objective function and the constraint. So, and then we want to display the status of the solver, which is whether it's optimal or continuous. And then I want it to print our answer of x1, x2, y1 and y2. So I put print variable dot name, which is will show our x1, x2, y1 and y2 equal to variable dot var value, which is it will show the value of x1, x2 and y1 and y2. And then we want to show our minimum value and print our answer of the minimum value, and then we will get this answer. So this is the answer that we get from the Python. The optimal solution is z equal to 3767.30772, x1 equal to 0, while x2 equal to 10.769231, and y1 equal to 27.5, while y2 is equal to 0. So we rewrite our answer in the form of the questions, and therefore to minimize the cost is by using 0 number of acres of farm 1 planted yam, 10.77 I round off it to 2 decimal point, number of acres of farm 2 planted yam, 27.5 number of acres of farm 1 planted potato, and 0 number of acres of farm 2 planted potato. And the minimum cost that will be used is 3,767.331. That's all.
Okay, hi. My name is Nofraisha Fatin. So here I will present about the question 3. In this question, we want to solve the minimum linear programming problem. So the objective function is minimum W equals to 2x plus 4y plus 5z plus 3q, such that our first constraint is here, negative x minus 2y plus 2z greater or equal to 40. The second constraint, 3x plus 2z plus q less than or equal to 100. And the third constraint is x minus 2y minus z plus 4q greater or equal to 50. And lastly, here is our sign restriction, which is x, y, z, and q must greater or equal to 0. So for this question, I have solved it using Excel solver and Python. For the Excel solver, we just need to put the coefficient of objective function and constraint into each column, into each column of x, y, z, and q. So here is our objective function, and this part is our coefficient for constraint 1, 2, and 3. So in this part, we use some product formula that will be generated by the Excel solver. We use some product by adding this constraint, this coefficient times the times objective function here. So for the sign, we put the sign which is same as the question, and right hand side is we put the value for each constraint. So this is the answer sheet that generated by the Excel solver. So next is the Python. So to use this Python, we have to import part, and next we have to declare our variable, which is x, y, z, and q. As we can see here, we use low bound equal to 0. This is show the sign restriction. Next, we state the LP problem, which is in this question we want to minimize the value, so we use a minimum value. And then here we state the objective function, and next we state our constraint 1, constraint 2, and constraint 3. Then we print the LP problem. So the solution for the output for the Python is here, and we can know that the optimal solution for this question is W equals to 152.5, X equals to 0, Y equals to 0, Z equal to 20, and Q equal to 17.5. So that's all from my part.
So my name is Zulaika binti Zakaria, and I will show the solution for question 4. Okay, so for question 4, we need to find the optimal solution of this LP, which is maximum z equals to 6x1 plus x2, and the constraint is x1 plus x2 less than 5 to x1 plus x2 less than 6, and our sign constraint is x1 x2 more than 0. Okay, we use Excel solver to solve this question. First we just put the coefficient of the objective function, which is 6x1 plus 1x2, and then our constraint is 1x1 plus 1x2 less than 5, and 2x1 plus x2 less than 6. And then for this we need to put the formula, which is we use some product and then just times between this cell with the number of the value of x1 and x2. Therefore, our formula will be sum product 6 times this cell plus with 1 plus this cell. This also same goes to the constraint, as we need to put the formula inside these two cells. And then we just use the solver. And this will be our decision variable cell, and this will be our changing variable cell, and then we just add both of these constraint, where this cell will be less than this cell and this cell will be less than this cell, and then we can get the solution. In order to get the more detailed solution, we just generate the answer report, and then we know that from the answer report, the value of x1 is equal to 3 and value of x2 is equal to 0, and our maximum is 18. Okay, next we also use Python to solve this question. We import pub, and then we use x1 x2 as our variable, and low bound is where the sign restriction, which is more than 0. And then this is also we need to put this whatever we want it to be, and then as our question is maximized, therefore we need to put LP maximized, and then our LP problem, which is our variable, is equal to objective function, We also can put the constraint, and then this will be our status, and then just generate the result. Therefore, the result is just the same as the status is continuous and it is optimal, where the optimal solution is same as SL solver, which is z equals to 18, s1 equal to 3, and s2 equal to 0. And then we move to the next question. We need to add constraint, which is 3s1 plus s2 less than 10 into the previous solution. And then as we use SL solver, we just add this constraint, which is constraint 3, inside the SL solver and repeat the step as before. And as we can see, the solution is just the same, which is value of s1 is still 3 and value of s2 is equal to 0. And our maximum is 18. And then same goes with Python. Just repeat the step before and we still can and then we add this constraint, which is the third constraint, and then the solution is still the same, which is z equals to 18, s1 equal to 3, and s2 equals to 0. Okay, so for next question, we still have to add constraint, which is s1 minus s2 more than 6. So before this we use less than, so now we use more than. The step is also the same. We just add the fourth constraint inside the previous solution we get, and then we generate the result as before. And then we can see the solution is same. However, when we generate the SL solver, the solver will say that this solution, that the solver cannot get the solution. And as we generate the feasibility report, the solution is infeasible as there is one cell that is violated, which we have the value of -3. Therefore, same goes with Python, just repeat the same step. And also same goes with Python, where the result is infeasible, the status of this is infeasible, and we can get the solution. Therefore, for C is infeasible solution, so the value is not, we do not need to put it. And lastly, we still add constraint, which is 8s1 plus s2 less than 12. And here is the fifth constraint. And as we generate the result, is also infeasible since this cell is violated, which there is value -4.5. Although there is value generated, but it is infeasible, therefore the last answer should be infeasible solution. Okay, that's all.
Okay, my name is Nia Batak Amali binti Hussein. My matric number is 198419. So for question 5, we have a maximum z equal to 4s1 plus 5s2, subject to 3s1 plus 2s2 less than and equal to 10, s1 plus 4s2 less than equal to 11, 3s1 plus 3s2 less than and equal to 13, s1, s2 greater and equal to 0 and integer. So we can see this here, the sign restriction is s1, s2 greater and equal to 0 and integer. So we can say that this question is integer programming problem. So to solve this integer programming problem, I'm used two methods. The first method is SL solver, and then the second method is Python. So firstly, we go to the SL solver. To solve it, the integer programming problem using SL solver, actually it seems like we solve it the linear programming problem. The difference is only at the decision variable value, because we need to assign this decision variable value and then we add into the constraint. Okay, firstly we need to make this table, and then we enter the variable, the decision variable. So for question 5, we can see that the decision variable is s1 and s2. So the next one, we enter the objective function.
we enter the value, the coefficient value of the objective function. For we can say that here is our objective function z equal to 4s1 plus 5s2. So we enter the value 4s1 and 5s2. And then we, for the constraint, we have here three constraints. So for constraint 1, we have the coefficient is equal to 3s1 and 2s2. And then for less than equal to 10, for constraint 2, we have 1s1, 4s2 less than and equal to 11. And then for constraint 3, we have 3s1 plus 3s2 less than and equal to 13. Okay, after we fill the objective function value, the objective function, the constraint, and then here, so here is the decision variable value. Actually here, this value will come out after we solve it using the solver. Also here. So firstly, we just here, we need to enter the formula which is equal to sum product, the changing value at the objective function subject to the changing value at the decision variable. And then for the constraint also same, equal to sum product, the changing value at the constraint 1 subject to the changing value at the decision variable. Same like the constraint 2 also equal to sum product, changing value at the constraint 2 subject to the changing value at the decision variable here. And then also for constraint 3, after we enter all the value into the table, we go to the data at the access solver, and then we find the solver, and then it will come out like this. Okay, so we set the objective first. So our objective here is here, we want to find the value of our maximum value. So here so here is our objective, and then our question is want to solve the maximum problem. So here we need to take the maximum, and then the changing variable cell. So here is our changing variable cells, and then we add the constraint. So we add from constraint 1 to constraint 3. So here is the difference between linear programming and integer programming. For integer programming, we need to add constraint at our changing variable cell here at the constraint and assign it as integer. After we add that, we need to we select a solving method, which is for integer programming we need to solve it using simplet LP. And then after that we solve it, and then after we solve it, we will get the answer. So the final value here, we will get the z equal to 18, and then value for s1 equal to 2, and value for s2 equal to 2 also. Okay, the second method is using Python. So to solve the integer programming or linear programming problem using Python, we need to install the pub library. So if you not install the pub library, you cannot solve the integer or linear programming problem. So first I already install the pub library, and then after we install, we enter the coding. Firstly, import pub.sp. So I'm using here pub.sp. If you don't want to use pub.sp, you need to write here pub and here pub.p. So here I'm just summarize it pub.sp. So I'm just write the sp here. So firstly, we need to assign our LP problem. So for question 5, we see that the LP problem is maximized. And then the second step is we assign the decision variable. So our decision variable is s1 and s2. So the difference between to solve the linear programming and integer programming, the integer programming, we need to enter the category here, which is the integer. Same also for the s2 variable, we need to add the category here as the integer. For linear programming, we do not need to add this category. So this is we assign our s1 as the integer and s2 also as integer. After we assign the decision variable, we assign the objective function. We can see that our objective function is equal to 4s1 plus 5s2. And then we assign our constraint, the first constraint, the second constraint, and then the third constraint. After that, we print our solution, our answer. And then we will get the optimal solution for question 5, we will get the s1 equal to 2, s2 equal to 2, and also our z equal to 18. So we can see here, using Excel solver or using Python, we will get the same answer, which is our z equal to 18, s1 equal to 2, and s2 equal to 2. Okay, next we move to the question 6, which is maximum z equal to 5s1 plus 6s2 plus 7s3, subject to 9s1 plus 12s2 plus 5s3 less than and equal to 14, 6s1 plus 4s2 plus 5s3 less than and equal to 30, s1, s2, and s3 greater and equal to 0 and integer. So we can see here, it also the integer programming problem, because here mention s1, s2, and s3 greater and equal to 0 and integer. So firstly, I'm using two methods also. The first method is Excel solver, and then the second method is Python. So from the question sheet, we can see that we have two constraints here, and then we have three decision variable. And then firstly, we need to make this table, which is our decision variable is s1, s2, and s3. And then we need to enter the coefficient of our objective function, which is 5s1, 6s2, and 7s3. And then a coefficient of constraint 1, 9s1 plus 12s2 plus 5s3. And then the constraint 2 is 6s1 plus 4s2 plus 5s3. And then we need, okay, so for here we left it without any values, so same also here and here and here. We just need to enter the formula, which is equal to sum product changing in objective function value subject to the changing in the decision variable value. So same like the constraint also, sum equal to sum product changing in value constraint 1 subject to the changing value at the decision variable. Okay, after that we solve it using solver. We just like I said before, for integer programming we need to assign we need to add the constraint of changing here our changing variable cell here as an integer at the constraint, and then we solve it using simply LP, and then we will get the answer for final value for z equal to 42, s1 equal to 0, s2 equal to 0, and s3 equal to 6. So okay, for the Python also the coding is the same, just here for okay, and then our LP problem is for question sheet is maximized, and then for decision variables, for question 5 we have only 2 decision variable, but for question sheet we have 3 decision variable. So we need to assign s1 also as integer, s2 also as integer, and s3 also as integer, and then we assign the objective function and then the constraint, and then we print the solution and print the answer. We will get the answer, our optimal solution, s1 equal to 0, s2 equal to 0, and s3 equal to 6, and our z equal to 42. So we can see here that if the answer for Excel solver and Python same, so we can conclude that z equal to 42, s1 equal to 0, s2 equal to 0, and s3 equal to 6. So even we use the Excel solver or the Python, we will get the same answer. So okay, that's all from us, group 4. Thank you.